All right, so this video is about factoring quadratics. I'm going to use this word a lot in this class, factoring. I use the word a lot from now on. So I want to start off by asking you just a basic question. It confuses a lot of people when we use this word factoring, I think. So I want to ask you this question. What is a factor anyway? So think about that. What is a factor? So for example, I'm going to ask you a question like, what are the factors of the number 12? You think, oh, the factors of number 12. Oh, those are the numbers that multiply together to be 12. And you probably list some numbers that multiply to be 12. You'd say 1 and 12. And then you say, well, 2 and 6 as well. And then you'd say, well, 3 and 4 also. So all these are factors of 12. Why are they factors of 12? Because they multiply together to be 12. So as we get into this factoring stuff, we start talking about what factors be this, that, and the other. Keep in mind, we're looking for numbers that multiply together to be the larger number, or the number in question, or the polynomial in question, and so forth. We're looking for what multiplies together to be it. So we write it with commas between, but technically we're saying, well, what is 1 times 12? Or what is 2 times 6? And what is 3 times 4? And a lot of times we write factors, we separate them with parentheses around them. Not commas and so forth, but parentheses. Why? Because we're saying these multiply together to be the larger number, the number we're working at, the number in question, or in this case, polynomial in question. So whenever in doubt, just know a factor are numbers that multiply together to be a larger number. So just keep that in mind. Okay, new question. It's kind of basic, but you have to understand the basics before we get to the harder stuff. So my question is, what are the factors of x squared? So think about it. Pause the video. Think about what they are. Actually think about it. And then you write down what the factors of x squared are. If you thought about it, you probably thought, well, x times x gives you x squared. So the factors of x squared are x and x. They have a product that's equal to x squared. And you're right. That's exactly what they are. So let's give you a new one. Here's a new one. What are the factors of x squared plus 3x? Let's pause the video, and I want you to think about it. What two numbers, or more than two numbers, that can multiply together to be x squared plus 3x? If you thought about it, you may have thought, well, x times x plus 3 will give you 3x. Because if you distribute x into it, you get x times x, which is x squared. And distribute again to 3, x times 3 is 3x. Hence what we begin with. So the product, or the factors of x squared plus 3x is x and x plus 3. You might write it this way. You might write it as x in parentheses, x plus 3 in its own parentheses. All those mean the same thing as the product of those two, equaling a larger number. Okay, I got another one just like the last one you saw. It says, what are the factors of 4x squared subtract 4x? I want to mention this, GCF. May you already know that means greatest common factor. GCF stands for. So you're looking for the greatest common factor that is both a factor of 4 and x squared and negative 40. So we look at that, or both of those divisible by 4, that may be the biggest number they both have in common. So if that's a GCF, you take a GCF, you divide each one by the GCF. So if I think my GCF equals a 4, well, I would take each term, 4x squared, divide it by 4, the 40, divide it by 4, and the number that I'm factoring out, I will put it outside of the parentheses. So that gives me 4, my GCF is outside. This reduces, the 4's cancel out, then be 1. Leave you with just 1 times x squared over 1, which is just x squared. Here, the 40 over 4 reduces to be 10, so subtract 10. So my GCF was 4, and I factor out that GCF, give me x squared subtract 10. For some reason, it confuses a lot of my students if I give them something like 2x subtract 10. And they think, what am I supposed to do? Well, it's the most basic form of factoring there ever is. You simply look for the GCF first. So when in factoring, always look for the GCF first. So GCF here, you probably know it's 2. So you factor out a 2, you're left with x subtract 5. So the GCF was 2, and what's remaining is x subtract 5, and their product is 2x subtract 10. So these are the factors. All right, so that's that basic stuff of understanding factors. Let's go a little further with it. Okay, new question. What are the factors of this? x squared, subtract 4. So if you want to figure out the factors of x squared, subtract 4, first decide if there's a GCF. First decide if there's a GCF, always. Always first decide this. Before you do anything else, always decide whether or not there's a GCF. It just makes life easier. So, is there a GCF of x squared and 4? No, there isn't a GCF of x squared and 4. But what's nice about x squared subtract 4 is the subtraction sign here. That makes a difference of two perfect squares. That's really, really nice to know. Why is it nice to know? Well, this is a special binomial. What is a binomial? Polynomial, two terms. There's a special one. What kind of special one is it? It is the difference of two perfect squares. Difference of two squares. What makes it great is if you have the difference of two squares, such as x squared subtract 4, when you factor it, you can basically factor it by taking the square root of each term. The square root of the first term, subtract the square root of the second term. And when you take a square root in math, we put a plus or minus sign between them. So this is x, square root of x squared is x. And then square root of 4 is 2. And then I put a plus or minus sign there. That means I have a positive and a negative version of this 2. So that means that this is really the same thing as x plus 2, x subtract 2. Meaning that this x squared subtract 4 simplifies to be x squared plus 2 times x squared subtract 2. And those are the factors of it. What are factors? They're numbers that multiply together to be the larger number. So that means if I multiply these together, I should get x squared subtract 4, right? So let's check it out. Actually multiply those together someplace and see if it gives you x squared subtract 4. So I'm check it over here. X times x, but it's x squared. X times negative 2, that's negative 2x. Positive 2 times x, that's positive 2x. Positive 2 times negative 2, that's negative 4. You add all that up, x squared plus nothing is x squared. Negative 2x plus positive 2x cancels to be 0. Subtract 4, it's the only thing left. So it does fall together to be what we began with. So that's an easy way of recognizing or factoring the difference of two squares. Because you have no GCF there. So you have to find other ways of simplifying it. And that is the way to simplify it. I'll give you another one just like it. All right, so try this one. What are the factors of 4x squared subtract 36? Pause the video and go and try it now. If you tried it, you might have first thought about, is there a GCF? Like I said, always do first. So hopefully you thought about that. If you didn't, you might have got the right answer. But I will first see if there's a GCF. And yes, there's a GCF. GCF is 4. But factor out a 4 from that means I take each one of those terms and divide them by 4. That will leave me with 4, and then x squared subtract 9. And that's it. And you may think, well, you know what? I think this is a perfect square, and that's a perfect square. And that is definitely a subtraction sign, meaning this must be the difference of two squares. If you recognize it, you should go further. This is the difference of two squares again. And if you didn't go further, I'll take off because that means you don't know how to factor. You should recognize this always to be the difference of two squares. So you know you square root each one of these. So if that's the case, when you square root them, you'd get the square root of x squared, subtract the square root of 9, which is x plus or minus 3. So your factors would be 4 times x plus 3, and then 4, or better yet, x subtract 3. So this is the only thing that expands. 4 times x plus 3 and x subtract 3. So that would be the factors of it. So that's how you factor the different two squares. All right, I got another example. Okay, so factor x squared plus 3x subtract 4. First thing you're going to look for is GCF. Is there one? 4, 3, and x squared. They don't have GCF. So they don't have GCF. The next thing we know is, well, is there a special type of binomial? Well, it's not a binomial. So it can't be a special type of binomial if it's not a binomial. So you couldn't recognize it being the difference of two squares. So another question is, how in the world do you factor this? It's three terms, and we want to figure out what multiplies together to be these three terms. Well, that's what I want to explain now. So I'm going to add a note right beneath here. So make this someplace else or whatever, maybe start it on another page, or just separate this little note from what we're writing right now. All right, so this is my rule for factoring trinomials, which we saw last. It was a three-term polynomial. So everything's in order: ax squared plus bx plus c. And the sign here in front of c, which would be the constant down in, this sign in front of c, in front of the constant, tells you some important stuff. One thing it tells you is, it tells you whether you have like or unlike signs. So that's what it tells you. So like signs, unlike signs. Like signs will have a plus sign there. So by having that plus sign, I know it's a like signs. If it's unlike signs, I have a subtraction sign right there in front of the constant term. So that's what that tells you. This sign tells you something else. So the sign here tells you the sign of your larger number. So whatever your larger number is between the two, it's going to have this sign on, positive or negative, whatever the case may be. All right, so keep that in mind. Let's go back to the example we had last. So this is how we'd factor this. Basically, we have to understand what all the coefficients are. Coefficient here is unknown, so it's understood to be 1. When we factor in this, we take this first term, first coefficient, and multiply it to the last term. So I call this my x game. On top, I have a times c. In this case, it's 1 times -4, so it's -4. On the bottom, we have b. B in this case is 3. Because remember, this is a, this is b, and this is c. So anyway, now what we're looking for are what are the factors of -4 and which ones add together to be 3. So we think about what are the factors of -4. You can start off 1 and 4. One of those can be negative and make it a -4. And you can think, well, 2 and 2 gives you 4. Then you think about, well, which of these pairs can somehow add together to be 3, positive 3? Well, you look at it, 2 and 2 won't add together to be positive 3. But 1 and 4, there's a way I can make it positive 3. If I made this 4 positive and the 1 negative, and you added those, they have a sum of positive 3. Hence, this is where unlike signs come from. 1 is positive, 1 is negative. That would be unlike, because that's a subtraction. Also, this is a plus sign. It tells me my sign, my largest number of 1 and 4. Well, which one is larger? Well, yeah, it's 4. So my 4 has to have the positive sign. So then my 4 is a little positive sign there. So anyway, and that has a little negative sign there. So that's what they are. So my numbers are -1 and 4. So what I want to think about my factors now, these are numbers are part of my factors. One of the factors is x, subtract 1. The other factor is x plus 4. Why? Because there's an understood little plus sign there on the 4. So those are my factors. Now I could check to see if it worked. I can fold these together to see if it really gives me x squared plus 3x subtract 4. So let's actually do that. So put it right at the side someplace and multiply them together, see if it worked. So here we are, we're checking it. X times x gives you x squared. X times positive 4 gives you a positive 4x. -1 times x is a -1x. -1 times positive 4 is a -4. When you add those, you wind up having x squared plus nothing, which is x squared. 4x plus a -1x is a positive 3x. And -4x plus nothing is -4. So voila, it gives me exactly what we started with, meaning that the product of these two gives me this trinomial. Hence, we factored it. We figure out what multiplies together to be this trinomial, which was x subtract 1, x plus 4. Give you another one, just for good measure, and make sure you understand this concept. Okay, so write down this example. X squared subtract 8x plus 12. Pause the video. Try to factor on your own. I'm going to come back and explain it. So pause it and give it a shot. All right, so we know we have 1 times 12 on top. So it's 1 times 12, well, that's 12, because it's a times c. On the bottom, what we have is b. B in this case is -8. Now we think about, well, all the numbers multiply together to be 12. You probably said, well, 1 and 12. Then you take 2 and 6, 3 and 4. Which one of those pairs can somehow add together to be a -8? But this can't, that can't. 2 and 6 could. I could use 2, I could use 6, but they don't add to be -8. Or to make them add to be -8, both got to be negative. If you notice, have like signs. They both had to have the same signs. Larger one had to be negative. The larger one is negative, and they're like. Should they both be negative? Yeah, they should. So my factors are x subtract 2 x subtract 6. You can check it to see if it worked, but it should. So we've now factored trinomials. Keep in mind this only works when leading coefficient is positive and it's 1. Other situations we look at tomorrow night. That's all I have. Good luck.